Today I'm going to teach you the basic concepts of Ohm's law, and also we will perform an experiment in virtual lab on Ohm's law, and also we will learn about the non-ohmic devices. So let us understand the basic theory of Ohm's law. A German scientist named Georg Simon Ohm gives the relationship between voltage and current in an electrical circuit. According to Ohm's law, the potential difference in an electrical circuit is directly proportional to the current supply. So if we replace the constant disproportionality sign with a constant of proportionality R, then V is equal to Ri. We will get this relation. Also, according to Ohm's law, the ratio of V and I remains constant. And here is the constant of proportionality, which we have written as R, where R is the resistance of the electrical circuit. So to understand this Ohm's law, let us perform an activity. Take a cell. This is resistance. Here we attach a voltmeter, and here is an ammeter to know the potential. Voltmeter is attached to know the potential difference of the circuit and in this electrical circuit, and ammeter is attached to note down the current in the circuit. So here we complete this circuit. This the current flows from here, and this is the current's direction. So when we attach one cell, make a table and note down the voltage, the potential difference and current reading when you attach one cell. Here is the table for number of cells. Now let us attach one more cell. Then again note down the reading of voltage and current. Make one another column V by I. Take the ratio of voltage and current, and at last you will see this ratio of voltage and current remains constant, which is our Ohm's law. So according to Ohm's law, the ratio of voltage and current remains constant, and the constant of proportionality is R, where R is the resistance of the circuit. So let us now perform an experiment in virtual lab. First of all, connect an ammeter in series to this resistance, and a voltmeter is attached parallel to this resistance box. Now take the resistance constant throughout this experiment and change the DC voltage and note down the corresponding potential difference and current reading in the circuit using this voltmeter and ammeter respectively. Change the DC voltage. First of all, check the connections, and we will get the right connections. Change the DC voltage and click on the add to table button. Then again change the DC voltage by the factor of 2 or 4 and add to table. Then again change the readings and complete this table. Now click on the plot button to plot a graph, and you will get a linear graph between voltage and current, which tells us about the confirmation of Ohm's law, which is that the ratio of voltage and current remains constant. Now check the Ohm's law for a diode. We know that this is a non-ohmic device. Set the DC voltage constant, change the resistance and add to table. Then change the resistance and complete this table. So now click on the plot button and we will get a non-linear graph between V and I. So this tells us that the ratio of V and I does not remain constant. So this diode is a non-ohmic device. The application of this Ohm's law. So Ohm's law, where we want, so what is the application of this Ohm's law? So as we know that this Ohm's law gives us the value of resistance, this constant of proportionality R, which is the resistance in a circuit. Resistance is basically the obstruction to the flow of current. So in many practical cases, it is necessary to increase or decrease the current. So we use a device known as rheostat. Rheostat, basically it is also known as variable resistance, in which if we want to regulate current without changing the voltage source, then we use a special device named as variable resistor or known as rheostat. And the unit of resistance is ohm. If we supply 1 volt potential difference through the circuit and also the current through that circuit is 1 ampere, then the ratio of 1 volt potential difference to the 1 ampere current gives you the 1 ohm of resistance. Test your knowledge by doing this quiz. What is the value of this resistor in ohm? Here is a resistor and we know that V is equal to IR, and the ratio of, according to Ohm's law, ratio of V by I remains constant, that is equal to R. So divide this voltage, voltmeter indication 12.3 volt. So here we will divide 12.3 to the ammeter reading 4.556 and we will get the result of R. 12.3 divided by 4.556, we will get 2.69. That is, the right answer will be 2.7. Similarly, if doubling the voltage across the resistor doubles the current through the resistor, then if you double the voltage and also doubles the current, what will be the resistance? See, if you double the voltage and also double this current, what will be the resistance? Resistance will remain same. So the answer to this question is the resistor value didn't change. Next, if the voltage across a fixed value of resistance is increased 5 times, what does the current do? The current will also increase by the factor of 5. What is the power in the given circuit? As we know that power is the multiplication of current and voltage. So voltage is 7 and current is 5. So the answer will be 35 watt. Resistance and current are, as we know that resistance and current is inversely proportional. R is inversely proportional to I. If current increases, then resistance will decrease, and vice versa. So the answer to this question is inversely proportional. Okay, thanks for watching this video. I hope you like this video.